Hello and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a few minutes. Today, we're going to look at the Database Deviation examine function, which can enable you to determine how closely the grid domains are capturing the underlying database geometry. The database or relative database deviation metrics can be applied to any domain, and the metrics are basically intended to estimate the deviation between the linear cell and the curved high-order cell that is projected onto the underlying database geometry. As you can see here in these images for the triangular and quadrilateral surface elements, both metrics are computed using the stencil for a fourth order or quartic surface element, which provides a reasonable estimate of the deviation observed during high-order grid elevation. The database deviation is calculated by sampling the cell using the fourth-order stencil and then projecting the high-order degrees of freedom onto the underlying database. Finally, the maximum projection distance or deviation for all the high-order nodes will be reported as the database deviation. Similarly, the relative database deviation is calculated in the same way, except at the end, the value is scaled by the maximum edge length of the linear cell. So let's look at an example. Here I have this pulse-shaped geometry on top of which I've created an unstructured domain. Anisotropic T-Rex layers are used along the rim of the geometry, while the interior of the domain is being meshed using isotropic cells. However, as you can see here, the grid resolution is not nearly enough to capture the wavy geometry with high curvature. Before we begin, note that the database deviation metric requires the domains to be database constrained and not free. Otherwise, there's obviously no underlying database entity that could be used to calculate deviations. So make sure the domains are DB constrained. Now, let's select this domain. Then, from the Examine menu, let's select Database Deviation. Just like any other examine function in Pointwise, you right away see the cells colored accordingly with the maximum and minimum values for the metric, in this case the database deviation, reported here in the panel. Additionally, you can hover your mouse cursor on the domain to use the probe functionality, which will visualize the curved fourth-order surface elements for you. As always, you can see the value of the examine function reported here in the bottom toolbar as you probe different grid cells. Remember that these values are in the actual grid units, so in other words, they are absolute values. Now, while still in the Examine panel, let's change the examine function to Relative Database Deviation. So you can see that now the values that are being reported are relative, which means that they are calculated relative to the actual edge length of the cell that is being probed. Okay, before we wrap up, let me make a couple of additional points. If the goal is to eventually elevate the linear elements to obtain a high-order mesh, then it is good practice to keep an eye on the maximum database deviation and to attempt to minimize deviation before actually starting the grid elevate operation. In fact, minimizing deviation for the domains results in less required curving and smoothing during the high-order grid elevation. The other point I would like to make is that the database deviation examine function can also be utilized for typical linear meshes in Pointwise to make sure that we have enough grid resolution in regions of high curvature. So in the example shown here, I have cells with an absolute database deviation of around 0.467 units with an average of 0.016 units deviation. So based on this information, I can select this unstructured domain, go to Grid Solve, and switch to the Attributes tab and open the cells frame. Here, we have the max deviation set to Not Applied. Let's change that to User Specified and enter our desired maximum deviation, let's say 0.01 units. Let's go back to the Solve tab and click Refine. Here, you can see that Pointwise has increased the grid resolution, which will reduce the amount of database deviation for this particular domain to better capture the underlying database geometry. Thank you for watching. If you liked this video, be sure to click the thumbs up button to subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.